Okay, so last video we had seen about the like 3 unit operations, process of unit operations that is dealt in the food processing industry. The other main operations are the drying and dehydration also. So drying is nothing but we all know that is we are removing a few amount of moisture content from any solid or from any semi-solid material by the process of evaporation. That is, it is having a change of phase from liquid to vapor or a gas. So this is the drying definition. Dehydration means we are completely removing the existence moisture and making into a bone dry condition. We call it as the dehydration process. So it involves both the heat and the mass transfer operations together only. Okay, so there are two bases that are widely used to express the moisture content. So since we are going to deal with the drying and dehydration, the main concept behind the both is the role of moisture content. So moisture content on the wet and the dry basis plays the major role. So what we mean by the moisture content wet basis means we are going to calculate a moisture content in any wet sample, that is we call it as the moisture content in wet basis. So the mass of water by the mass of the moist sample. So how much amount of water divided by the moist sample, that we call it as the calculate the moisture content in wet basis. The same applies to the dry basis, nothing but after drying process the amount of water per unit mass of dry solids that are present in the sample. So that means like after the process of drying, few amount of moisture would have escaped from the particular sample. After drying the process, we are going to calculate the moisture content in dry basis, that is mass of water by mass of dry solids. So this is the concept behind the moisture content in wet and dry basis. So why we should go for drying or dehydration process, let's see. So first, to eliminate or to remove the moisture which may lead to the decrease in the product shelf life, that is the stability will get affected if moisture is content more than the estimated or the required level. Next, to improve the or to keep the good properties of a product or a material, that is the flowability or the compressibility of the particular property, the particular how to say, the characteristics of the particular material has to be maintained. So in order to that, we go in for either drying or dehydration to reduce the cost of transport of large volume materials, so liquids. So mainly to check the flow of the liquids, we can go in for the drying process to make the material easy or more suitable for handling. And the final step is like evaporation, filtration and the crystallization. So mainly to extend the shelf life of the food products by reducing the water activity of the food materials. So in this picture, we can we can categorize that this drying process takes place in almost two stages, that is the initial, first and the second stage we are categorizing, with the moisture content in the x-axis with the drying rate in the y-axis. We can understand like there is a study in the drying rate, that is how the changes in the drying rate can be understood. Is that initially we can see in the picture where the drying initial adjustment is being done, and A is the point where the rate of drying is starting. So once when the drying process starts, initially there will be a constant rate period, and where up to a level of percentage moisture removal, there will be a first fall in the constant rate period. So there will be a first fall rating period, and where there will be an second fall also, where it has been dried completely to a safe level. So in between that second critical point and the second falling rate, we are going to learn about the equilibrium moisture content also. So this is the concept behind the drying process, or the changes that occurs during the drying process. So the first initial adjustment period, so the time that is corresponding to the A and B will represent the initial. So from the diagram, if we can see that A and B represents the first initial adjustment period. During this period, what happens is that the solids will absorb the heat and the temperature will increase and the moisture will just begin to evaporate from that particular drying solid. So at that time, after this period, the temperature will stabilize, that is, heating and the cooling will almost become equal from this AB stage. So this temperature is equal to that of the wet bulb temperature of the drying air, and it is referred by the point B. So they are telling that at the point A and B only, that drying temperature just begin to start. So only we are attaining a constant time drying period. Okay. So this the temperature we are telling that it is equal to the wet bulb. So the wet bulb temperature, if we look for the wet bulb temperature, means it is like almost equal to like in drying hair. So in drying hair, if we see, 1 second. So next is the in this we can see that A dash and the B dash will represent a drying period when the sample is taken from reactor at high temperature to a dryer at a low temperature. So here initial adjustment period, we can see a hot air which comes inside, the temperature will increase. At the time the evaporation process starts and the temperature will start to decrease. So at equilibrium, the rate of heating will be equal to the rate of working also. So this only represents at the A dash and the B dash. So next, as I told, there will be a constant rate period. So that is the B and C. So in that diagram, we can see the first diagram, the BC will represent the constant rate period. The temperature remains constant and the rate of drying also is constant at this time. And also at this stage, the temperature is almost the same to the wet bulb temperature, and the moisture evaporating from the surface of that particular solid is replaced by the water diffusing from the interior of the solid. So in this, as the water is freely moving, so a particle size of the solid will influence the drying rate. So what happens in the constant rate period is, when hot air comes inside, there will be a diffusion inside the particular solid material, and where at the time of evaporation we can come to a conclusion that the evaporation rate will be equal to the diffusion that is taking place. The both will be the same. Okay. So the critical moisture content means the moisture content at the end of the concentrate, at the end of the constant rate only we call it as a critical moisture. It is nothing but a point below which the movement of that moisture from the interior is no longer sufficient to saturate the surface. Okay, the next is the third is the first falling period. Now we are going to see the C and D. So the C and D gap time period only we call it as the first falling rate period. So during this time, the surface water is no longer replaced at a rate fast enough to maintain a continuous film on the surface. What happens is that the dry spots like water surface itself will begin to appear and rate of drying will begins to fall off. So at the first falling rate period, the temperature of the solid surface is above the wet bulb temperature, and that point D is only we call it as the second critical point. So in this we can tell, like, there will be a dry spots on the top layer during the first falling rate period. Along with the diffusion, what happens is that there will be a like dry spots present on the top. During the drying process itself, we can find like spot like dried spots on the top of the material. So that we can come to a conclusion that the surface, the film of that surface water is completely evaporated, so that the evaporation rate will be greater than the rate of diffusion. Okay, Next is the second falling rate period. So the D to E corresponds to the second falling rate period. So during this period, what happens is that the rate of diffusion of water vapor will be equal to the rate of drying only. Okay, so this is why the reason is the rate of drying will falls even more fastly than the first. So first falling rate, when we compare, the drying process will be lesser when compared to the second falling rate. It means during the phase of second falling rate only, the drying process will be more. Okay, so during this period, the rate of drying is dependent only on the rate of diffusion of vapor of moisture to that of the surface of the solid. Okay, next, beyond E, the drying rate will be equal to 0. So after E, if we see, there is the 0 drying rate. Hence the temperature and the moisture content will remain the constant. So beyond the point E, continued drying is a waste of time only, because we have almost evaporated all the moisture that is present in the material. So coming to the methods of drying, we can categorize. So as we all already seen, the mode of heat transfer is been taking place. So we are dividing the methods into conductive drying, convective drying, and radiation drying. And other methods are like dielectric drying, chemical or sorption drying, sack, and the freeze drying. So conductive drying is nothing but in this method, like the principal mode of heat transfer and the vaporized moisture is removed independently of the medium that we are used for heating. So the main concept behind conduction drying is when the heat for drying is transferred to the wet solid mainly by conduction through a solid surface. The phenomenon is called as the conduction or the contact drying. So mainly what happens due to the conductive drying, how it is characterized is heat transfer to the wet solid takes place by conduction through a solid surface, usually a metallic surface, and the source of heat may be hot water, steam, or flue gas, or any hot oil, and the surface temperatures may vary widely, and the contact dryers also can be operated under low pressure and inert atmosphere. Any dust or dusty materials can be removed very effectively by the use of conductive drying when it is agitated. That means when it is like mixed, a more uniform dried product along with increased drying rate is achieved by use of conductive drying. So it is more beneficial. Convective drying is nothing but the drying agent, that is the hot gas that we use for drying, in contact with the wet solid, that is in contact with the wet solid, is mainly used to supply the heat and carry away the vaporized moisture. So it will carry away the moisture and the heat is transferred to the wet solid mainly by convection. So the characteristics of convection drying are: drying is dependent upon the heat transfer from the drying agent to the wet material, and the former being the carrier of vaporized moisture. So drying temperature here, it varies widely, and the steam heated air or direct flue gas of agriculture waste can be used as a drying agents. So if the atmospheric humidities are too high, the natural air drying needs to be dehumidification. And here the fuel consumption per kilogram of moisture evaporated is always higher than that of the conductive drying. So last is the radiation drying. This is mainly based on the absorption of the radiant energy of the sun and its transformation into heat energy by the grain. Here sun drying is a main example of the radiation drying. So how much amount of energy is being absorbed and how much it is transformed. Okay, so moisture movement and the evaporation is caused by the difference in temperature and the partial pressure of the water vapor between the grain. So main concept between this drying is nothing but the temperature and the evaporation only. So mainly it is based on the how much amount of the water is being evaporated between the grain and the surrounding air. The effectiveness of this sun drying will depend upon temperature, relative humidity of the atmospheric air, speed of the wind, and the type and the condition of the grain. So based on this radiation drying will be happening. Thank you.